Now, logically, if we just found GHA, you'd expect that the next thing we do is we find LHA. However, we're not going to go on towards that next because it's actually easier to first find declination. So remember, the three things we need, the three values we need to find to perform the celestial calculations is local hour angle, declination, and assumed latitude. And while GHA is used to find local hour angle, declination is something you find out of the Nautical Almanac, and GHA is something you find out of the Nautical Almanac. So usually you see people find GHA, then find declination, then move to local hour angle. So I'm sorry that it kind of throws off your pacing to go from all of these calculations to something that feels unrelated, but it is ultimately the more practical and the easier way to do it. And actually, it's something you could do at the same exact time. You don't need to do all of this and then go over to the declination side. You could do the two simultaneously, and you'll see why in a second. So if we move on to declination, I'm going to leave this column to the side here for the LHA stuff. But for declination, what I'm going to do is I'm going to write it off to the side here. So the declination column looks like this. We write dec H, little d, and then dec. And it's the same process. We're doing the same exact thing. We need the hourly declination, and then the little d correction to get from the hours to the minutes, and then we'll get the true declination at the time. Now, it's important to note the declination, the latitude of the sun, changes a lot less than the GHA of the sun. You know, the sun does a full 360 degrees around the Earth every single day, whereas it takes 6 months for the sun to go from 23 degrees south to 23 degrees north. So over a single hour, GHA is going to change by like 14 something degrees. Well, exactly 15 degrees. Yeah, I was just guessing before, but yeah, no, it's by precisely 15 degrees. A declination over a single hour is going to change by like 0.5 degrees total, depending on the time of the year. So you're going to see that this all comes out to much smaller values. But we'll get straight into it. So we're going to need to go back. Oh, I'm working on the 21st of November. So let's just go back to the 18th of August, just so we still go in the same order that we have been. We're going to write dec H, little d, and then dec. So working with the 18th of August problem, we're going to go back to the same page that we had opened in the daily pages before. So the 18th of August page. Here's August 7th, 18th. So August 18th, we flip to the sun side. Here's the 18th down here. And just like I said, this column is dedicated to GHA. This column is dedicated to declination. So right next to our GHA value is the declination for that same time of the day. So you see down here I marked 1700. We can just follow that value across to the side. And you can see they don't always write the same degree value because it doesn't change that much. But you can just, if it's 13 here, it's 13 all the way until you go to the next one, which is also 13, all the way down here. And then here you can see it changes. So for this one, it's still being affected by the one above it. So you could read the value of this declination at 1700 as north 12 degrees, 58.4 minutes. So that's where we're going to write here. North 12 degrees, 58.4 minutes. Remember the north. The north means that the sun is in the north, which, if you think about it, August, we're in the summertime, of course the sun is in the north. Now the next thing you need from this page is the little d value down here. Now what this little d is, it's how much does the sun change in declination each hour? It's a scale factor. It's how much does it change per hour. So you can see right here it's 0.8. If we go back, here's a good example. At 1400, we had north 13 degrees, 0.8. Then at 1500, we had north 13 degrees, 0.0. Then at 1600, we had north 12 degrees, 59.2. So you can see each hour, we're just subtracting 0.8. And that process continues all across these 3 days. It changes slightly. So if we go to the next week, it'll probably, it's 0.9 the next week, or this is actually 2 weeks later. It's still 0.9 the immediate next week. But then 2 weeks later, 0.9. So every hour, the declination changes by exactly 0.8. So that's what we're going to use for this, 0.8. Now, what you also need to remember is you need to add a sign to this. It's either positive or negative. And whether it's positive or negative is dependent on whether the sun is moving towards the equator or away from the equator. Because obviously if we're going towards the summer solstice or the winter solstice, the sun is going towards its farthest point north or south. So the declination is increasing in either direction. If it's going away from that towards the equinox, then it's decreasing in either direction. So you could either figure this out based on looking at the date and saying, oh, is this before or after the equator? Is it before or after the equinox? Or if that doesn't make sense to you, you can just come back to the actual declination calculations and you can see, oh, throughout this whole day, declination is slowly decreasing, which makes sense. It's August. The equinox is in like early October, late September, mid-September. I don't remember exactly. So we're after the solstice, coming to the equinox. So we're coming close to the sun being exactly on the equator, meaning that this is negative 0.8. Now that we have that, we can come to the increments and corrections section right here. And we know that our hour, or our minutes, were 36 minutes, 12 seconds. So we go back to the 36 page, right there. And now, like I said, this section is GHA. This section is declination and some other things that are related to declination. So we're going to use this section. And what we do is these left columns are the little d value that we found off of the daily pages. And then the right column in each box is what that d value would be equivalent to scaled down to specifically these minutes. So basically, if we did 36 divided by 60, so 36 minutes out of a total of 1 hour, how many minutes of arc would that be equivalent to if the change in declination per hour is only 0.8 minutes of arc? It's just interpolation. It's just setting fractions equal to each other. So all you need to remember is we were looking for negative 0.8. So we come to this section for the 36 column, this 36 box. We come down to 0.8. We look across and it's equal to 0.5. So now we write negative 0.8 is equal to negative 0.5. And then this is the value we're actually going to apply. So if this is how far north the sun was from the equator at the exact time at 1700 GMT, negative 0.5 minutes is how much that declination changed in the preceding 36 minutes, 12 seconds. So we subtract negative 0.5 from the 58.4 and we get 57.9 minutes. So north 12 degrees, 57.9. That is our true declination at 17:36:12 on the 18th of August. Now we're going to do the same problem for the 4th of June. So So we write dec H, little d, then declination. Okay, now we're going to come to the 4th of June for the daily pages of the next problem. Here we've got May, June 6th, June 4th. We come to the sun section, and this problem we're also looking for 1700 on the hour. So we're going to come down to the 4th at 1700, come across, and you can see we're north 22 degrees, 28.6 minutes. So north 22 degrees, 28.6 minutes. And you can see this is a much higher number than our previous problem, which makes sense. This is June. The summer solstice is like June 21st most years. So June 4th is only a couple weeks away from the summer solstice, meaning the declination is going to be really high. So this is totally reasonable. Next, we need the little d value. So we come back to our declination column, and we look down at the bottom of the page, and you can see here, little d is equal to 0.3. That's also reasonable, because as we get closer and closer to the solstice, the sun changes its declination a little bit slower every hour. Because, you know, the curve is rounding out at the top there. So at the top here, it's only changing ever so slightly every hour, whereas further down the changes are more extreme. So 0.3 makes sense. But is that positive or negative 0.3? Well, remember, this is before the solstice. So the sun is getting higher in the sky at all times, meaning it's positive. And if you wanted to double check that, you could come here and you could see at 1500 it was 22 degrees, 28.1. At 1600 it was 28.3, 1700 was 28.6, then 28.9. So you can see the numbers are going up as we go down the line. So we know definitively that the little d value is positive. Now we need to find what that d value is equal to if we convert it to just minutes and seconds. So our minutes and seconds are 15 minutes, 20 seconds. So we're going to come to the increments and corrections section. That's too far. There we go. And we're going to come over to 15. Here's 16. 15 is over on this page. There. And now remember, GHA is over here. So we're working with declination. And we're looking for what 0.3 is equal to. So here's 0.3. You come across, and you could see at the 15-minute mark, 0.3 is the equivalent of 0.1. So even though in our entire hour, the declination would have increased by 0.3 minutes, in only 20 minutes, or in only 15 minutes, it increased by 0.1 minutes of arc. So we add the two, and we get north 22 degrees, 28.2 minutes of arc. All right. I'm going to do that one last time for the 21st of November problem. So you know the deal here. We come to the daily pages, flip over to November. What is it, 21st? Okay, here's November 24th, November 21st through 23rd. Right here. So here's the information we need for this day. We're looking for, I flipped over 2 pages. We're looking for November 21st at 0300 GMT. So we come over. Here's 0300. The declination at this time, which is the same time that we got our GHA, is south 19 degrees, 52.4 minutes. South, 19 degrees, 52.4 minutes. Remember, it's November. It's the winter time, or it's fall, but it's about to be the winter time. Which makes sense. That means that the sun is in the southern hemisphere, so that's why our declination is labeled with a south. Also, before we even look down, you know now that we're going from the autumnal equinox and we're moving towards the winter solstice in just around Christmas time, so December 21st-ish, meaning our declination should be increasing. Now it's increasing to the south, but it's still increasing. So if we come to little d here, you can see at the bottom of the page, little d is 0.5. 0.5. And we've already said it's plus. If you don't believe me, you could look at all of these declination values. You can see at 0200, it was 20 degrees, 05.0. Then at 300 is 05.5, then 06.1. So we're increasing by just about 0.5 each and every day. But that's per hour. We need to correct that to our exact minutes and seconds. So we're at 16 minutes. Remember, declination, you don't really care about the seconds because it changes too slowly for the seconds to matter. So we just come to the 16 minutes column, which is right here. We look at the declination section, sorry, and we're going to come to 0.5. So at 16 minutes, a change of 0.5 minutes of declination is also equivalent to 0.1 minutes. Because we're so early in the hour, we've only gone about a quarter of the total distance that we're going to. So we're essentially at 0.1. So we say plus 0.5 is equal to plus 0.1. Then we can say our declination is south 19 degrees, 52.5 minutes. So to review, you find your declination on the same page that you find your GHA. Then you find your little d on that same page, but towards the bottom of the column section. And then you correct all of that by going to the increments and corrections section and finding what your little d value is equivalent to at your specific minute value. And then you apply that to your original hourly declination and you get your declination for the exact time. Now, this is why I said it's valuable to do both of these at once. Because realistically, what you could have done, if we go back to the 18th of August problem, is you could have just said, oh, hey, open my daily pages to 18th of August, and you look at the GHA, or the GMT of 1700 on the 18th of August would have this GHA and this declination. You could have copied both of them down at once, and then you could have gone and copied the little d. Then you could have gone to the increments and corrections and found that correction and this correction, and then you could apply them. So that's why people do GHA and declination at the same time usually, just because it's faster to do them together. There's no reason to flip through the book twice as many times as you would have needed to if you just did it once. But overall, it's good to break these down for our purposes. And now we're going to go on from here to find our last two values, the LHA and the assumed latitude.